Hi, everybody. I'm Ping from the Humanitarian OpenStreetMap team. And it is my great privilege to be here with you to talk about our work with low-cost drones. I'm a technologist, and this is a technology demo. But I want to start from why this matters. All communities need maps to function. Maps are necessary for disaster preparedness, mitigation, response. Maps are necessary to know where to place public health, services, infrastructure. Maps are necessary to understand populations and their needs. Humanitarian actors can't manage what they can't see. Conflict-affected communities need data as much as any others, possibly more because they're especially vulnerable. And yet, at the same time, places affected by conflict or at risk of conflict are systematically data scarce. Government and institutional mapping systems have often broken down. Commercial coverage, data in these regions may be missing or outdated because the situation changes so quickly. And so geospatial data is just yet one more way in which conflict-affected communities are underserved and disempowered. This is the Kakuma refugee camp in Kenya. 200,000 people live here. This camp was begun in 1992, so people have been living here for decades. In 2021, we went to try to collect aerial imagery to make a map with a professional mapping drone. This was a $15,000 fixed-wing drone. It weighed about 4 kilograms. And unfortunately, that's a pretty scary-looking object to a customs official. It was seized by customs, and it took us years to recover the drone. And when we finally recovered it, we hired the Kenya Red Cross to fly it. It's not a simple thing to fly a drone like this. It was relatively expensive. And the local residents weren't involved in this process. Wouldn't it be great if there were a way to get high-quality, high-resolution imagery with an inexpensive drone that's small enough that it can't be weaponized, and so regulators are more willing to accept it, and also a drone that local residents could learn to fly, and maybe even get paid to do it, so their communities can build capacity and even benefit financially. That's what we're trying to build with Drone Tasking Manager. It's an open source platform for commercial-grade mapping with hobby drones. And we're building it in the open, co-developing it with our partners NACSA in Nepal and OpenDroneMap. And I want to just walk you through the process of collecting aerial imagery using Drone Tasking Manager. So I'm going to create a new project and give it a name. And the first thing I need to do is define my area of interest. So I'm going to take us into an area in Sierra Leone where we've been doing some of our mapping experiments. If I have a polygon that's been predefined, I can upload that polygon. Or I have the option of just drawing the area in the map. So I'm going to draw a rectangle on this map where I want to collect some aerial imagery. OK, that looks pretty good. So once I've defined my area of interest, I can set the resolution of imagery that I'm looking for, in our case, 5 centimeters per pixel, the amount of overlap I want between successive images, and what kind of output I'd like. Would I like 2D imagery or even a 3D model? I'm going to turn on terrain following, which I'll explain in a moment. Now, to map a large area, you need to divide up that area into work units, right? Because a drone has a limited amount of time it can fly in the air. You need to divide it up into areas that can be covered in a single flight. So I'm going to specify that I'd like to break this up into 400 meter squares. That doesn't fit my region too well, so I'm going to try maybe 450. OK, that looks pretty good. So I'm going to go ahead and create the project. And now I've got it set up with these. The region is divided into 12 tasks that are ready for drone pilots to go fly. So a drone pilot can log into the system and claim a task. By locking it, they assign it to themselves. So we can distribute the work among many drone operators. And Drone Tasking Manager has created a flight plan. So a drone can methodically fly over the whole area and collect imagery that covers all of it. And by default, the takeoff point is the center of the area. And right now, it's made a flight plan flying from south to north. But suppose I know this region, and there's actually a better point for me that's more accessible, a better place to take off from. I can move the takeoff point to a new location and recalculate the flight plan, and it's decided to reverse the plan. Now it's flying from north to south. OK, that flight plan looks pretty good to me, so I'm going to download it and put it on my drone flight controller. And on a flight controller, it looks like this. If I zoom in, you'll notice that the waypoints have varying altitudes associated with them, and that's the terrain following I was referring to earlier. If you're flying over hilly terrain, then the drone also needs to fly up and down to match the terrain to maintain a consistent altitude over the ground, so you have a consistent level of detail in your imagery. Now, ready for drone pilots to go out and fly this imagery, collect photographs with their drones. And you end up with a big pile of photos on an SD card. So let's suppose I've flown 2 of these tasks. And so I've got about 500 images, which I can upload into Drone Tasking Manager. OK, the upload process typically takes a little while, so I'm just going to skip ahead. That's done. And then the next step is to classify the imagery. So we've learned in our experience that when you do a big data collection project like this, some of the images come back with problems. They might be blurred or too dark or taken at the wrong angle. And so this classification step involves having a Drone Tasking Manager goes through the images and detects problems like this. This also takes a few minutes, so I'll skip ahead. You'll see it's found 4 images that have issues, and I can open them up and have a look to see what's happened. So each of those green dots is a location where a photograph was taken from. You can see I've covered 2 of those task squares. If I look at the images that have issues, here's a red dot. It says, camera must point down. So this image was taken at the wrong angle. If I inspect the image, sure enough, it's a picture of the horizon. This is not the kind of imagery we want. We want images that are pointing at the ground. OK, so I agree with its decisions, and looks like it's classified the imagery correctly. I'm checking out one of these tasks. It looks like I've covered the whole area pretty completely, and I'm ready to mark this area fully flown and ready for processing. And so the final step is then to process the imagery and stitch it all together to make a 2D model or a 3D model. And I can do that at the individual task level just to see each square. Or after I've flown the entire area, collected imagery for the whole area of interest, you can do final processing to put it all together. And the result looks something like this. So over that whole area, when you collect imagery at this resolution, you end up with this kind of level of detail. This is just from a hobby drone, but it's detailed enough to identify vegetation, building materials, do damage assessments. But 5 centimeters is not enough to identify faces, so privacy is protected. We did an experiment last year to scale this up. We went to Freetown, Sierra Leone, and worked with the Freetown City Council and Slum Dwellers International. And we trained a team of 14 to fly the drones and process the data. They were a mix of university students and residents of the slums, of the informal settlements. They captured over 100,000 photos and covered an area of 80 square kilometers at this resolution, 5 centimeters a pixel. And this is what they ended up with. So that same level of detail that you saw earlier, but they were able to cover a really large area, most of the city of Freetown. And this is 14 people with 6 drones, and they collected this imagery in about 3 weeks. You can use that same imagery to make a 3D model of the area at this level of detail. So where we are today is with Drone Tasking Manager, we're able to collect and enable residents to collect high-resolution imagery with an inexpensive quadcopter weighing under 250 grams. That's an important threshold for regulations. So under 250 grams is a special class of aerial vehicle that's easier to accept. And I just want to be clear, we're not saying that it is appropriate to fly drones over all conflict-affected communities. What we are saying is that conflict-affected communities have a pressing need for geospatial data, and we think it is an ethical imperative to directly involve and benefit and sustain the members of those communities in the process of collecting and using that data. And the work we're doing with low-cost drones is about making possible that involvement. Thanks for your attention.